So we are finishing lesson 1 from unit 4. We started it Friday. We pretty much worked on it from bell to bell. Today, we just have a little bit more to get through, and then you should have time to work on your practice. Now, my first hour had hardly any time because they would not stop talking, so that's on them. Either way, you guys know what's expected from you. I spend like the first few minutes of every class going over what's expected of you as far as like assignments and deadlines coming up and all that stuff. So here it is. The lesson from Friday is recorded and linked in the slides if you need to watch it, just like they always are. The practice is a puzzle piece with the same name as the lesson. And just to let you know, moving forward, I'm not going to be reminding you about your binder check. If you're wanting to resubmit it for whatever reason, maybe it was completely missing, maybe you just didn't get a good grade on it, maybe you were absent. Regardless of the reason, that's on you to say, hey, Miss Medina, can you check my binder? And then unless I'm in the middle of teaching, I will check it and update your grade. Other than that, you have until the end of this month to resubmit it. Otherwise, I don't have to accept it anymore. And it is worth like 50 assessment points. So make sure like we're not letting those just go down the drain. The next quiz that will be coming up is over lessons 1 through 5. This week, with it being slightly shorter than normal, probably won't get to it. So sometime next week is when you can expect it. Just know since it's over lessons 1 through 5, whenever we finish lesson 5, the next day will be the quiz. So any questions on that? Definitely use the practices as your preparation for the quiz, and definitely use the quizzes as an additional study tool for the unit test. Question, Landon?
The week is shorter.
There's no school on Friday, Veterans Day. All right, so that's why. And also just a few other general announcements for this class. I won't be here tomorrow, but as always, I always leave stuff for you to do. So whether you do it or not, it's still on you. It's still going to be on your test. So either you know it or you don't. Either you practice it or you don't. So just like normal when I'm absent, I leave a video for you to watch. I leave some sort of note sheet for you to fill out that you will then upload to Schoology. So that way I can see that you did the lesson as you were told, because you're given a whole hour. And then you have a super short practice to work on. So the practice is a puzzle piece. All of that information is in the slide. So tomorrow's November 8th, you click on the November 8th slideshow. That's where you'll find the video. That's where you'll see the instructions for how to submit your stuff. Never give anything to the sub. You submit it online, and that's how I grade you. So any questions on that? All right, so I won't be here tomorrow. On Wednesday, Mr. Cashett, our principal, will be in here observing this class, just so you know. So come in here with your best intentions, as you always do. I'm not saying like don't act natural, but just like be aware, like he's gonna see who's paying attention, who's not, who's participating, who's not. So come in ready to learn and ready to answer whatever it is I throw at you. So there's that. And just because he's here doesn't mean I won't address certain behaviors, because I absolutely will. I'm not afraid of that at all. So anyway, that is all I need to notify you of. Now on the note sheet that you picked up today, because we're finishing the lesson 1 from unit 4. First, we're going to talk about the difference between dependent and independent variables. So dependent variables and the definitions are typed up for you already. You just have to understand them. So if that means you need to rewrite it or give yourself a few examples, that's what you need to do. But a dependent variable is a variable representing the output of a function. What letter usually represents output? Good. So a variable representing the y of the function. So if I have like an input output table, x is normally my input, y is normally my output. And usually it's the y that depends on the x. Usually for the x, we pick whatever numbers we want. And then for the y, it depends on the x. Like usually there's some sort of equation that goes with each table or some sort of circumstance. And then the y depends on the x. So that's one way to think of it. The equation y equals 6 minus x. Like if I use this table and the equation y equals 6 minus x, what would my first y value be? If this is my equation for this input-output table, it would be just 5. Because what's 6 minus 1? So then what's my y when x is 2? No, it's 6 minus x, 4. What about when x is 3? What's my y? And what about when x is 4? What's my y? So the y depends on what the x is. Make sense? No? I see some people looking confused. So if it doesn't make sense, let me know and I'll try and explain it a certain way. But if this is a relationship between x and y, the output, which is usually our y, depends on the x. Therefore, our independent variable is a variable representing the input of a function, which input is usually represented by x. All right, and then it has the same exact verbiage used as before. You can pick whatever you want to be for the x, and y usually depends on it. So what does it mean to be like independent? That's what I'm trying to get you guys to be, is independent. But what does that mean? You rely on yourself, like you don't rely on anything else, right? So that you can think of it that way. Usually I think of it as a graph, because that's usually what it leads up to. Like yesterday, we were looking at, or not yesterday, but Friday, we were looking at the time since an owner like left his dog tied to a post versus the dog's like distance from the post. What depends on what? Does the distance depend on the time, or does the time depend on the distance? Distance depends on the time, and guess what? Distance is on what axis? So that makes sense that it is our dependent variable. And then the time is on the, and that makes sense because it is our independent variable. So that's how I always think of it. And another way to help you remember, you can make a D out of the y-axis and the y-axis only. So anything that's on the y-axis depends on the other variable, right? You can make an I technically out of both axes, but that's how like I remember it. You can make a D out of the y, so that's our dependent variable. You can make an I out of the x-axis, that's our independent variable. Questions on that? All right, think of another example and then share with your group of like an independent and a dependent variable. So what's like another situation that we can make a graph for? Discuss that in your group, so that way we can put a couple more on our notes. Give you like 30 seconds. Raise your hand and give me an example of two variables where one's dependent and the other's independent. What'd you guys talk about in your group? Nothing? Just something that depends on something else. Yeah. So child depend on parents. That is true. I don't know how I would put that on like an X and Y axis. So what else could we come up with? What about, we could put number of ice cream sold versus number of sales. Right? Do the sales depend on the ice cream sold, or is it the other way around? Sales depend on the ice cream sold. So did I label my graph correctly? Yes. Someone give me something else. Maybe like we could put temperature for our x-axis, because is temperature independent or dependent? Independent. What's something that depends on the temperature?
The weather.
So like, I don't know, what should I put here? Inches of rain? What else could I put there? What else depends on the temperature? Number of sunburns? Like literally anything that depends on something else.
Water park.
Water park ticket sales? Literally almost anything. As long as what's on the X is independent, like you can't make the temperature change, can you? Outside? You can't. You can't, I guess, I don't know, you can't make the number of ice cream sales change, like it just depends on how much they buy. So things like that. You can't make the time change, but the distance depends on how much time has passed for that one dog. All right, now here's a new situation. Time in seconds since the dog owner left and the total number of times the dog has barked. So in your groups, you're going to figure out what's independent, what's dependent, write it down in your notes. Blank is a function of blank. So is it the barks is a function of time, or is it that time is a function of barks? Figure that out. And then I'll have one person from each group go to whiteboard.fi. And you will sketch a graph showing that relationship. So sketch a possible graph of the number of barks versus time that has passed. And see what like it can possibly look like. So do that. If you're a singleton, try it yourself. Try it with a Chromebook. You can still discuss with other people, but every group should have a Chromebook out. I'll put the code up for whiteboard.fi in a second. Now, I do have a good amount of responses. Now, for what depends on what? Do the number of barks depend on how much time has passed, or does the time that has passed depend on the number of barks?
The time.
So I disagree. I don't think that time can change based on how much the dog barks, right? That's not true, right? So Brian, what you said was incorrect, sorry. Time does not depend on the number of barks. The number of barks depends on the time. So which ones can we probably say are eliminated based on that? All right, so this one didn't turn in anything, so that would have been like a 0 and a constructed response. This one I could give partial credit, but, oh wait, no, this one I could give more credit to than this one. Because what's wrong with this one? These should be flip-flopped. Time should be on the X. Number of barks should be on the Y, because the time is independent of the number of barks. So this one looks good so far, looks good. Again, needs to be flipped. So far, we're done with those. Now, some of you that did plot, stop talking. some of you that did plot something on your graph, let's see if that makes sense. So this one doesn't have tick marks. Let's just make some tick marks down here. I'll use the same ones as from Friday. So they counted by 40 or 20 seconds on Friday. What do you think we should put for the number of barks? What would be reasonable?
20.
Should we count by like 1, 2, 5? Okay, 5 might be reasonable. Would it be reasonable to have like counting by hundreds?
No, probably not.
No, unless that dog like never ever stopped barking, then
Swallows.
probably count by 5s. Or something similar, something that's reasonable. Now, do you think that the graph would be a straight line? Could I have a fraction of a second? Yes, could I have a fraction of a bark? No, and that's kind of what these continuous lines would implicate. That I could have like at about 30 seconds, who knows? 6.5 barks, I don't know, but because you're putting a continuous line, you're making it seem that way when it's probably not. So that's one thing you need to notice. Graphs that have continuous lines, guess what they're called? Like the ones we looked at on Friday. These would be classified as continuous graphs. Just so you know, maybe write that on your notes from Friday because that may come up again. You do continuous graph if both variables can be like fractions of something. Like, can I have a fraction of a foot? Can I have a fraction of a second? And isn't it like constantly some sort of distance away from the post at all times? Yes, so that's why it was continuous for the example from Friday. Now for time, and again, I don't have mine labeled, but we would have like separate dots. Maybe something like this, who knows, this is just one example. So sketch that on your graph. Do you know what these types of graphs are called? Well, they are. Line graph. These ones aren't lines. So when it's separate dots, they are called discrete graph. Well, now you know it. So you need to know the difference between discrete and continuous. So discrete are separate dots. Okay, I'm getting ready to just make you guys sit in rows from now on. Like, how hard is it to stop talking while I'm talking? Like, be better. Like, I hate like constantly nagging at you, but it's super rude. Like, if you were my athlete, I would make you run until like the end of practice. And that's why I love when you guys do sports, because then I could just tell your coach and then that's what they'll do. All right, questions on discrete versus continuous. All right, and if you didn't already, make sure that you have time on the x-axis. And for this one, number of barks on the y. So to fill in this sentence, is it number of barks is a function of time, or is time a function of number of barks? Good. So number of barks is a function of time. Because do you think that as more time passes, the barks increase or decrease? Kind of just depends on the dog, but yeah, I would think that it would increase because they're probably getting worried about their owner. All right, usually I put D depends on I. And so whatever is the dependent variable, like number of barks, depends on the independent variable, like the time. And I know that D comes first because it's D's further up in the alphabet than I. All right, and that pretty much about covers it. Like we kind of discussed these already. So Yeah, any questions? All right, then you have 4 solid minutes to work on your puzzle piece. So kind of same like first hour, the longer it takes for me to like get the class settled, the less time you have to practice. But it's only like 5 questions. So work on them. You can pack up at 9:44, not earlier than that.